Benzene is a cyclic structure that has a molecular formula of C6H6. Whenever we want to represent a benzene is represented by a cycle, and that cycle has three double bonds. It's an alternation of a double and a single bond. You can start numbering if the benzene has no substituents. You can start numbering anywhere you want on the benzene. It's not, it doesn't follow a rule. So I can start numbering, for example, from this carbon as carbon number 1, this carbon as carbon number 1, and as you go. But if you start numbering from one carbon, you have to continue down the double bond in there so that you can finish up the cycle. So the numbering here is going to be 1, 2, this is the 3, this is 4, this is 5, and this is 6. Now, when you represent benzene, there are two different representations actually for benzene, because those double bonds that you see in the benzene, these are double bonds that can move along the cycle in there. So you can represent the benzene by having a double bond between carbon numbers 1 and 2, or you can represent the benzene by, if I keep the same numbering, and there, here you go. You can represent the benzene like this here. You have to start numbering from the double bond. So just number anywhere. I'm just going to start numbering from here. And that is going to be 1, 2, this is a 3, this is 4, and this is 5, and this is 6. These two structures are the same. So notice here, between carbons, between those two carbons, you know what, let's keep the same numbering so that you can relate, because it really doesn't matter here for the numberings. There are no substituents on the benzene. So let's keep the same numbering so that you guys can relate in there. And see that these two structures are actually the same. Between carbons 1 and 6, here I have a double bond, here I do have a single bond. But as I said, because benzene is so special, the double bonds in there move along the benzene cycle. So whether you represent the benzene in this structure or you represent the benzene in this structure, both are the same. So this is why when we want to represent the benzene, we combine both of these structures together, just showing that the double bond can be anywhere in the cycle. And to do this, we just draw a circle, and there in the middle, just showing that the double bond can be anywhere along the carbons of the cycle there. So that double bond there, they can be anywhere between the carbons of the benzene, carbons of the benzene. Okay, whatever I just drew over here is the skeletal structure of the benzene. So this is the skeletal structure for the benzene, all of those, and benzene has a DBE of 4, because benzene here has made up of a cycle. Is made up of a cycle and 3 double bonds. So that is going to be 1 plus 3. It's going to be equal to a DBE of 4. Now, if I want to go ahead and represent benzene by the structural formula, because after all, benzene is a cyclic hydrocarbon. It's made up of carbons and hydrogens in there. So this is it. This is how I represent the benzene if I want to go ahead and show the carbons and the hydrogens. Every single carbon here has 1 hydrogen in there. And if we go over the hybridization for each carbon, because it is an alkene, every carbon is 1, 2, and 3 groups. So every carbon is going to be an sp2 hybridization. So this carbon is an sp2 for each one of these carbons in there. sp2 means a trigonal planar. And if it's a trigonal planar, then all of these carbons, they lie in the same plane. Just think about it. They all lie in the same plane. I do have here a double bond between these two carbons. So this is a pi bond, this is a pi bond, and this is a pi bond in there. So I do have 3 pi bonds. I have 3 pi bonds for this structure, and the rest are sigma. Let's count them, how many sigmas we have. So that is going to be 1, 2, 3. This is going to be 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a 12 sigma, and I do have 3 pi bonds. Now remember that when we work with pi bonds in there, this means that every single carbon, as we did in the valence bond representation, it does have a p orbital in there. And that p orbital has 1 electron. So when I am drawing the p orbitals of the benzene in there, I do have 6 p orbitals. Every carbon has a p orbital in there. So I do have 6 p orbitals in there. Here you go. So this is a p, this is a p orbital in there. And those, every 2 p orbitals, they overlap to make a pi bond. The p orbitals have 1 electron. So these two, they overlap to make a pi bond. These two over here, they overlap to make another pi bond. And these two over here, they do overlap to make another pi bond. Electrons, they move from one p orbital to the other. And this is why we said, because electrons move from one p orbital to the other, we can have an overlap between these two, an overlap between these two, an overlap between these two p orbitals, so the electrons can be anywhere around the cycle, and this is why we represent it as a circle. Okay, so you have to imagine as if benzene is an electron-rich structure, and the reason why it's an electron-rich, because you do have an electronic cloud, and that electronic cloud is because of these p orbitals that are overlapping with each other, and the electrons, they they lie above the plane of the benzene, and they lie also under the plane of the benzene. So electrons, they are above and below the benzene ring, and that will make the benzene electron rich, and it will make it stable. Benzene is very special because of this, because of being electron rich and because of being stable. And we're going to give it the name aromatic. So aromatic, which we represent by an AR, is a special characteristic that is given to cyclic compounds and compounds that have an alternation of double and single bonds, because those compounds, they are electron rich. Electron rich because their p orbitals overlap in there, and they overlap above the ring and below the ring. Now, with respect to the nomenclature of benzene, it actually depends on how many substituents you have on the benzene. So let's say if you have a monosubstituted benzene, meaning that if you have a benzene with just one group on it, regardless what that group is. So from now on, we're going to draw a benzene with a circle in the middle. So let's say if I have, like, for example, a chlorine over here. This is called a monosubstituted benzene because the benzene has one group on it. And I can represent, if benzene has one group, I can draw this group anywhere on the benzene. So I can, for example, draw it like this. So if I can do this. And these two are the same. I can draw the chlorine on the benzene over here. And again, all of these are considered to be the same, where if I want to name it, then I'm going to always start numbering from where the substituent is on the benzene. So this one is always going to be carbon number 1, and the name is going to be chloro. And normally when you name benzene, if it's a monosubstituted benzene, the ending is going to be a benzene. So that is going to be chlorobenzene. And that is considered to be the IUPAC name. For benzene, there are some common names that you would need to memorize. And we'll go over each one of them. Okay. So all of those are monosubstituted benzene because they only have one substituent on the benzene. And if this is the case, we're going to give that substituent number 1. And notice that if it is on carbon number 1, we're just going to drop the 1. So I don't say 1-chlorobenzene. It's nonsense to say the 1 because the chlorine is the only substituent on the benzene. Same thing for the CH3 here. It's a methyl. So I'm going to name this as a methyl benzene. Methylbenzene is the IUPAC name, but we rarely go with methylbenzene. Instead of methylbenzene, we go with toluene. And toluene is the common name. Guys, whenever we're talking about common names, they have no rule. And because they have no rule, we have to take them as is. Toluenes are used as solvents. These are hydrocarbons, and normally a structure with a CH3 and a benzene. Instead of calling it methylbenzene, we call it toluene. So we go with the common, we don't go with the IUPAC. Same thing for the OH and the benzene. OH means hydroxy. So if I want to name it as an IUPAC, this is called a hydroxy benzene. No space in there between hydroxy and benzene, and that is going to be the IUPAC name. However, we go with the common, and the common is called phenol. So that is going to be the common name. We know it more with the common than the IUPAC. So toluene is known more than methylbenzene, and phenol is known more than hydroxybenzene, and these you are responsible to know. Now, if you have a carbon that is connected to the benzene, directly next to the benzene, this carbon is called a benzylic carbon. So this carbon in here is called a benzylic carbon. And that benzylic carbon, you guys, we're going to name it as a benz. This is the rule. So that is going to be called a benz in there. Now, whatever comes after the benz represents the functional group that you already have. This functional group is an aldehyde. So your ending there, it's going to be a benz aldehyde. And benzaldehyde is known to be both IUPAC and common. And we use it. We always use it whenever we are representing a structure like this. This is called a benz, and it's an aldehyde. Same thing here. This is a benzylic carbon as well. So this carbon is a benzylic carbon. But the functional group that I have here is not an aldehyde. This one is a carboxylic acid. So this is why the ending of this is going to be a benz, but the ending is going to represent the carboxylic acid, and carboxylic acid ends in oic acid. And again, this one is both IUPAC and common. Okay. If you have an NH2 on the benzene, two names for it, IUPAC and common. So the IUPAC name is called an amino benzene. We rarely go with amino benzene, by the way. Amino means NH2. So amino is a name given for NH2 substituent. So amino benzene is an IUPAC. We go with the common for this one, and the common is going to be aniline. It's going to be aniline. I wrote it wrong in there, so that is aniline, and that is going to be my common name. So that structure is known as aniline more than as amino benzene. For this structure, this is an NO2 and it is nitro. I just want you to see the difference between the amino and the nitro. The nitro is NO2 and that is called nitrobenzene. And this is going to be the IUPAC and the common. Okay, both. OCH3 on the benzene, this we name it as an alkoxy. Alkoxy means an alkane, any alkane you have. Here it's a CH3, so it is going to be a methoxy. So the name is going to be a methoxy because it's a substituent, and then the ending is benzene. And that is going to be the IUPAC name. It goes by a common, which is anisole. So anisole is the common name for methoxybenzene. Okay, let's say, for example, if I had something like this, if I had an O and an ethyl group in there, and this is a CH3, then I'm going to name this as ethoxybenzene. And no common name for it. Anisole is just for the CH3 that is connected to the oxygen. So that is going to be the IUPAC name. Okay. If you have two substituents on the benzene, now for the two substituents on the benzene, we're going to follow a different system, and the different system is going to be using simply indication where these substituents are. If the substituents are on carbons 1 and 2, then I'm going to call the system ortho and dash. If the substituents are on carbons 1 and 3, then I'm going to call that system meta. And if the substituents are on carbons 1 and 4, I'm going to call the system para. Okay, I'm not done with the name, but it's just like I am here differentiating between two substituents on the benzene, because the benzene having two substituents, it can have those substituents on carbons numbers 1 and 2, 1 and 3, or 1 and 4. So I'm going to continue the rest of the name, and the name is going to be dichloro. And of course, it's going to be benzene. Notice that the ortho will replace the 1,2. So when I say ortho, I don't have to say 1,2, because if I say ortho and then I say 1,2 dichloro, why did I say ortho to start with? Because ortho represents 1,2. So I either say ortho or I say 1,2 dichloro. Chlorobenzene. Although with benzenes and disubstituted benzenes, we always use the ortho, meta, and para, and we rarely use the 1,2, the 1,3, and the 1,4. We can also, instead of saying ortho, we can do an O in the dash and then the dichlorobenzene. Any one of those is the same, okay? But it's better that you go either by the ortho dichlorobenzene or the O dichlorobenzene to represent a system of 1,2 substituents. Meta, that is going to be 1,3. Sorry, with meta you don't have to use 1,3 in there. So it's going to be meta, and then it's going to be dichlorobenzene. Or I can do 1,3 dichlorobenzene. Again, don't use meta if you're using 1,3. So if you're using 1,3, drop the meta. Or I can do M and the dash and then dichlorobenzene. It's better to use the meta instead of using the 1,3. Okay. Para, it's going to be para again, dichlorobenzene, or it is 1,4 dichlorobenzene, or it is P dichlorobenzene. You guys, the ortho, meta, and para, so the ortho, meta, and para, we use them only whenever we have two substituents on the benzene. That's it, not more than that. So if you have two substituents on the benzene, whether the substituents are the same or different, it doesn't matter. you use the ortho, meta, or para, depending on where these substituents are. There are, of course, exceptions. There are always exceptions in there. And the exceptions are when you have two groups that are present or more that are present on the benzene. And one of them is considered to be a common root. Now, what is a common root? A common root there are from the monosubstituted benzenes that I just showed you. All of those are considered to be common roots. So you do have a CH3 connected to the benzene. Toluene is considered to be a common root. Phenol is considered to be a common root. Benzaldehyde, benzoic acid, all of those. The aniline is a common root. In there, the methoxybenzene is a common root. So whenever you see any one of those, in there, the ending has to be in them. The ending cannot be in the benzene. And then I need to give them the lowest number possible. So here, I do have toluene. This whole thing is toluene. And because this whole thing is toluene in there, the carbon of the CH3 is going to get the lowest number possible. So this carbon is going to get the lowest number. And if it gets the lowest number in there, this means that I need to start from it. And then the second substituent gets the lowest number. So I have 1, 2 in there. I know that 1, 2 is ortho, so I'm just going to go ahead and put O in there. I'm going to name the chlorine, which is the chloro. And then I'm going to name the common root, which is toluene. By putting toluene at the end, I took care of naming the benzene and the CH3 in there. So instead of saying ortho, chloro, methylbenzene, you don't say methylbenzene, you go ahead and you say toluene. So the ending is toluene, and toluene will be a common root. And this is why I started numbering from there, giving the lowest number. Same thing, methanol. Same thing, phenol. So phenol is considered to be a common root in there. This means that I would need to give the carbon of the OH the lowest number. So that carbon in there is going to get the lowest number. And then when I number, it's going to be 1, 2, 3, and 4. I can go either directions. I can go 1, 2, 3, and 4 here, or 1, 2, 3, and 4 there. Both directions will give me the ethyl to be on carbon number 4. On carbons 1 and 4, I have my substituents. So my name is going to be para, and it's going to be ethyl. And then the common root in there, it's going to be phenol. I could say for ethyl, phenol, because definitely this one is on carbon number 1. And I could say over here 2-chloro, toluene, because definitely the CH3 of the toluene is on carbon number 1 in there. So either one of these are right. So the rule here is that whenever you are naming as a common root, you have to give the lowest number to the root name. So the lowest number to the root name, you have phenol, you have toluene. If you have, for example, something like this, if you have both, if you have a phenol in there and you have a CH3, so let's do that. So you have both in there. Which one is the higher priority? The phenol is the higher priority. So if the phenol is higher priority, I need to give the phenol the lowest number in there, and then proceed to give the CH3 the second lowest number. These are on 1-3 position, so it is going to be meta. And I have my methyl in there, okay? And then I do have my phenol. So your ending is going to be in the phenol. It's either meta methyl phenol or 3-methyl phenol. Any one of those, and both of them is going to be right. Okay, now 3 or more substituents, you cannot use orthometa or para. Orthometa and para, these are just for 2 substituents. So 3 substituents, please don't use orthometa and para. You have to name in a way to give the lowest sum of numbers. Your substituents need to get the lowest number possible in there. And what is the lowest number in here? It makes sense that I start from this carbon there, and then continue over here. This is 1, 2, 3, and 4. This is the lowest sum of number in there. If you start numbering from here, from this carbon, going this way, then you're going to increase the number of carbons in your substituent. If I start numbering from here and go this way, then again, you're going to have more numbers in there. The sum of numbers is going to be more. So this is why you always number to give your substituents the lowest number, the lowest possible number. And now my name is going to be, that is going to be 1, it's going to be 2, and it's going to be 4, and it's going to be dash. You have 3 chlorines in there, so it's going to be trichloro, and you have your benzene. Okay. Again, no ortho, no meta, and para. If you have a common root, your common root has to be on carbon number 1. So common roots are toluene, they are phenols, they are aldehyde, they are benzaldehydes, and they are benzoic acids. These are our common roots in there. So for this one, my common root is going to be the phenol. Okay, this is going to be my common root in there. It's going to be the phenol. So I am going to give the OH the lowest number. And then I have 2 possibilities. I can go this way and give the CH3 the lowest number, the carbon number 2. Or I can go this way and give the ethyl number 2. In this case, both are going to get number 2. So I go with the alphabetical order. E comes before the M. So this is why I need to go this way. This is going to be 2, it's going to be 3, 6 over there. And the name is going to be 2-ethyl, 6-methyl, and then phenol. Okay, this is a methyl group, and that is going to be an ethyl group. Same thing for benzaldehyde. My common root is the benzaldehyde. So this is going to be my common root in there. It's the the aldehyde and the benzene. This is going to be my common root. And then I'm going to move along the chain to give the second substituent the lowest number. And that is going to be carbon number 5. So if I want to name this, this is going to be 2,5-dichloro, no dash. Okay, it's not going to be no dash in there. It's going to be benzaldehyde. Okay. Now, if you have a chain and you have a cycle coming off the chain, a benzene coming off the chain, then in this case, if the number of carbons in the chain is more than that of the benzene, then benzene is going to be a substituent. Okay, your ending is not going to be in the benzene. The benzene is going to be a substituent because the chain has more carbons than the benzene. So if benzene is a substituent, always, whenever we name benzene as a substituent, we are going to call it phenyl group. So benzene is called a phenyl group, and it is replaced by, or it is represented by a pH like that. So the name over here, I'm going to give the substituent the lowest number possible, and then my longest carbon chain is going to be all the way here, and that is going to be 8 carbons. So my 1, 2, 3, 4, 5, 6, 7, and 8. So my name here is going to be 3. On carbon number 3, I do have a phenyl, and then I have the octane. Okay, so on carbon 3, I have a phenyl and I have an octane. So always take that benzene to be a substituent, and that benzene, we are going to call it a phenyl group.